Here are some other harder trig equations which we need to solve. Remember, we are looking for all solutions between 0 and 2 pi. That would be going around the unit circle once. Remember, you start out at 0 degrees, which is equal to 0 radians, or 360 degrees, which is 2 pi radians. And we want all the solutions within that one loop around the unit circle. All right, cosine 2x equals to 1/2. The problem is we have a 2x here. That's going to cause us some problems. So I'm going to relabel this. I'm going to say, let's let theta equal to 2x. And so basically I'm looking for cosine theta is equal to 1/2. Where is cosine theta equal to 1/2? We've done some similar to this. If cosine is equal to 1/2, that puts me at 60 degrees, or pi over 3. This is the point 1/2 square root of 3 over 2. Remember, cosine is your x value, sine is your y value. Where else is cosine equal to 1/2? Well, let's reflect down into quadrant 4. And I want the ones between 0 and 2 pi, so I want to go around this way, not choose the negative angle, so this is going to be 5 pi over 3. So this means that theta, to solve this equation, is going to be pi over 3 and 5 pi over 3. The problem is we're not looking for theta, we are looking for x. Theta is equal to 2x. Now, this is where it gets tricky, is I have to basically divide by 2 here, right? In order to find x, I have to divide everything by 2. But that means I'm going to miss solutions, because if I divide by 2 here, that means I need to go around this unit circle not just once, but twice in order to get all the ones within 0 to 2 pi. So let's go around again. So I have pi over 3, and if I take that and I go around again, remember this is going to be 6 pi over 3, that's 2 pi. Okay, so this is also going to be 7 pi over 3. So I'm going to have pi over 3, 5 pi over 3, and 7 pi over 3. And let's take the 5 pi over 3 one, and let's go around again a whole 2 pi more. So if you add 2 pi, which is 6 pi over 3, you're going to get 11 pi over 3. So I took pi over 3 and I added 2 pi, which is 6 pi over 3, which gives me 7 pi over 3. I took 5 pi over 3 and I added 2 pi, and that gave me 11 pi over 3. So I have 2x is equal to these 4 options. Now we're going to divide by 2. So I'm going to take all this right here, and I'm going to divide by 2, which is going to give me a pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So notice 11 pi over 6 is still less than 2 pi, and so that gives us all the angles between 0 and 2 pi. Let's do another one. Tangent of 3 theta equals 1. Again, I have a 3 theta here. I'm going to call that x. These are just letters, so I know that x is equal to 3 theta. Actually, I'm going to write it the other way around. I'm going to say 3 theta. Remember, in this case, we're going to be looking for theta is equal to x. And where on my unit circle does tangent theta equal to 1? Well, let's look. That means sine and cosine are the same. So remember, we have a square root of 2 over square root of 2. This is at pi over 4, or 45 degrees. But we also have minus square root of 2 over 2 minus square root of 2 over 2. Both those angles have tangent of the angle equal to 1. So we have pi over 4. So that's one solution. And we have this guy here, which is going to be 5 pi over 4. Now the problem is we have to divide by 3. Remember, we're looking for theta. We're looking for theta, not x. we have to divide by 3, which means we have to go around the unit circle 3 times. 3 times. So let's start at pi over 4. So I'm going to go around one more time, so I need to add the 2 pi. 2 pi is 8 pi over 4, and that's going to give me 9 pi over 4. So that's another option here. And because I'm dividing by 3, I need to go around one more time, so let's add 2 pi, which would be 8 pi over 4. So I'm going to get 17 pi over 4. So I have my 3 options here from my pi over 4 location. Now let's do the 5 pi over 4. I have the 5 pi over 4. I'm going to go around another 2 pi, and 5 pi over 4 plus 2 pi, which is 8 pi over 4, is 13 pi over 4. That's around the second time, and now I want to go around one more time, and so I have to take 13 pi over 4, and I'm going to add 2 pi to that, and I'm going to get 21 pi over 4. So there is my 3 values for the 5 pi over 4 location. Now I'm looking for theta. I'm looking for theta, not x. So now let's divide by 3. So I take all of those and I divide by 3, and that means that theta is going to be, well, pi over 4 divided by 3 is going to be pi over 4 divided by 3, so that's pi over 12. Okay, and you guys can work through the algebra for that. I got pi over 12. I got 5 pi over 12, that's from this guy. I have 9 pi over 12. I have 13 pi over 12. I have 17 pi over 12. And I have 21 pi over 12. Now we can simplify some of these, so let's do that. And so my final solution then is going to be theta is equal to pi over 12, 5 pi over 12, 9 pi over 12 simplifies to 3 pi over 4. I get 13 pi over 12, 17 pi over 12, and 21 pi over 12 simplifies to 7 pi over 3. Oh, 7 pi over 4, sorry. I do want you to notice that every single one of these is less than 2 pi. So notice there are 6 different solutions. Here's another example. I've got a cosine squared and a sine x. And obviously I'm going to solve for x. And x is some angle between 0 and 2 pi. Well, I can't do much with the cosine and the sine, so we need to get it down to one trig function. And if you recall Pythagorean's theorem, cosine squared x is going to be 1 minus sine squared x. So let's plug that in. So I'm going to distribute my 2 in, and I'm going to get 2 minus 2 sine squared x plus 3 sine x is equal to 0. It looks like I have a quadratic equation, and I don't like negatives in front of my quadratic, so I'm going to move everything over to the other side. I'm going to have positive 2 sine squared x minus 3 sine x minus 2 is equal to 0. Well, we need to factor that. And you know, it kind of looks like a 2u squared minus 3u minus 2 is equal to 0. So if I was going to factor that, I'd have a 2u here and a u here. I need a minus 2 somewhere. I'm not quite sure where. Let's do a guess and check. So if I did this, I would get a 2u squared minus 4u, first outer inner, plus u minus 2. And that's exactly what I have here. So now I can rewrite this, if I factor it, as 2 sine x plus 1 times sine x minus 2 is equal to 0. So now I have something times something equals to 0. And now I have to solve each of those individually for values between 0 and 2 pi. So let's do that. I have 2 sine of x plus 1 is equal to 0. Subtract your 1. 2 sine x equals minus 1. Sine x equals minus 1/2, and that we already solved. And we found that x was equal to pi over 6, and nope, that's not right. I need a negative 1/2, so I'm here and I'm here, and that would be x is equal to 7 pi over 6 and 11 pi over 6. And from this one, we're going to get sine of x equals 2. Now remember, sine is your y value, and it's going to bounce around between -1 and 1. It never equals 2. So this one has no solution. Therefore, for this equation right here, the only solution is between 0 and 2 pi is x equals 7 pi over 6 and 11 pi over 6. Here is a slightly harder example. I got cosine 2x times cosine x plus sine 2x times sine x equals 0.45, and you're given instructions to round your answers to 4 decimals, which tells me that you can use your calculator. There's 2 ways you can tackle this. Method number 1 is, well, let's just do it the way we've done all the other ones until the very end, then we plug it in the calculator. This looks like an identity to me. Remember, sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. So this is going to be cosine of 2x something x, and I need to flip the sign, equals to 0.45. I'm using the trig identity. Cosine, 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 sine, cosine, cosine, sine, sine, sine. So this means that cosine of x is equal to 0.45. Where is that on the unit circle? Well, this is positive, and so I know we're in quadrant 1, and the x value is 0.45, and I can do a cosine inverse of 0.45 to give me that this angle, x, is going to be 63.256 degrees. Okay, so this is the angle. It's 63.256 degrees. We don't want the answer in degrees, we want it in radians, so flip your calculator over to radian mode, and you will find that this is going to be 1.104031 radians. But remember, the inverse function only gives you the angle in the restricted domain. So we need to find the other one between 0 to 2 pi. So for a positive x value, it is right here. Now, this is a positive 63.256 degrees. This one is going to be 360 degrees minus 63.256 degrees. Because remember, we got to go all the way around this way, and it's 360 degrees minus that angle. But again, we don't want the answer in degrees, we want the answer in radians. So instead of 360 degrees, we're going to have 2 pi radians minus the angle in radians, 1.104031. You can plug that in on your calculator, and you will get 5.17 8875 radians. So this equation has 2 solutions. We're going to have x is equal to 1.104031 radians, and x is equal to 5.178875 radians. That's method number 1. Let's do method number 2. Here we go. I plugged in the left-hand side of my equation, cosine 2x plus times cosine x plus sine 2x times sine x. Okay, I've got that plugged in here. And I plugged in the right-hand side as the second equation, 0.45. And now let's graph that. And look, I get a nice curve here. Check your window. Now make sure you're in radian mode. We have to make sure you're in radian mode. And let's check our window, minus 10 to 10, that's fine, x. I want between 0 and 2 pi. So I could actually change that window a little bit. Let's go from minus 1, and 2 pi is 6 or 7, so let's just go up to 8. The scaling is where you put your tick marks, and let's do like a minus 5 to 5. I really only care about that minus 0.45. So you notice the answer to the solution to the equation is the intersection. So notice I have 1, 2, this third intersection here might be outside the 0 to 2 pi. So I'm going to look here as a solution, here as a solution, and I'll check that one to see whether or not it is less than 2 pi or not. I don't think it is because we did it the other way and we only found 2 answers. So I'm pretty sure there's only 2 answers to here, but let's check. So let's go back to here. Let's find my intersection. So second calc. Let's go down to intersection. My first curve is my blue curve. That's my y1 is cosine 2x times cosine x. Notice it's up at the top. So that's my first curve. Hit enter. My second curve is the one in red. Hit enter. And let's do a guess for the intersection right about there. And it says I have x equals to 1.10431. Well, that's good. That's exactly what I found right here. Okay, that's exactly what I found right there. So that matches. Let's go back and let's find the other one. So second calc, intersection, and my first curve is the blue one. That's great. My second curve is the red one. That's great. And let's do a guess where the intersection is. That's right over here. There's my intersection, and it says 5.1791543. And if I go back to my previous solution, that's it. So that gives me the exact 2 same solutions, and frankly, that's a lot easier, guys. Now let's see what happens to that last one, okay? Is this last one over here bigger than 2 pi? So if I do a trace, now I'm watching my x values here. Notice how x is right now at 6.0909. Now 2 pi, take your calculator, go 2 times pi, 3.14. Okay, so 2 pi is roughly 6.28. So let's go back to here and keep going our trace, and notice we are past, look at the x value here, we are past 6.28. So this intersection here is actually the second time around the unit circle. It is not a solution for between 0 and 2 pi, so we can ignore that. So therefore, if I am using my calculator, method number 2 is basically you're going to plot the left-hand side, which is this cosine 2x, cosine x plus sine 2x, sine x, as your y1 and your TI-84. Plot your right-hand side, 0.45, and then find your intersections. Just make sure you get all the ones that are between 0 and 2 pi.